ladies and gentlemen. My name is Zachary Smith. I'm joined here today with Christopher Logan, Nicholas DeLuca, and our technical director, Mr. James Brown. And we are Team Hasbro with Project Android. Android stands for Automatic N-Sided Dice Roll Identifier. Now imagine for a moment that you're playing a board game. You're rolling the die. The die is a completely chance-based action, but it determines whether you win or you lose. Now, take it a step further. You're playing this same board game, but on the computer. And how do we simulate this roll? Well, at the moment, we use a virtual random number generator. To many players, this has a simulated feel and doesn't feel like true chance. So Hasbro's solution is to create a device that allows the player to roll their own die at their house, take this value, and use in-game. For Hasbro, they will be able to have an optimal market position, as this is a unique product to the toy and gaming industry, and therefore sales will be high. Our best anticipated outcome is this device that is battery operated, portable, non-intrusive to your gameplay, and has an attractive design. On the software side, it must be able to accurately identify these pips and digits as values. At the moment, our current prototype does not have this attractive design. However, our second is in the workings. This system diagram is the entire scope of our project. Those highlighted in blue are what we worked on this semester. Our project is broken up into both hardware and software aspects. And to talk more on the hardware, I would like to turn it over to Mr. Christopher Logan.
Thank you, Zach. So from a hardware aspect of our project, we have three main goals. Goal number one is to detect a die roll. Goal number two is to react to said die roll. And goal number three is to capture an input for our software to process. On the right here, you can see all of our hardware systems in a wire diagram, and I'll begin to explain these in the next couple slides. Goal number one, detect a die roll. Currently, we are using pressure-sensitive technology to detect a dice roll. So, when a die or dice are rolled onto the pressure sensor, it emits an analog voltage spike, which goes into our analog to digital converter and is converted into a binary output signal, which is being monitored by our Raspberry Pi board. Goal number two, to detect a roll, to react to the roll, I'm sorry. So after the Raspberry Pi board has realized that a roll has occurred, we begin to illuminate the play surface with LED strip lighting. These lights allow the camera to warm up and focus on what it needs to capture, which brings me to the third aspect of our project, the capturing the input for the software side. So on the right here, you can see a 3D printed custom camera mount that the camera is attached to. This was designed and built by our team this semester. This allows the camera a better angle to capture an image with. Also, the camera itself has many settings within it that we are using to filter out the background, just so we can get a more clear image for the software to process. To talk more about the software processing, I'm going to bring up Nick.
So, on the software side, we have two main scripts, both of which have been written in Python, and they were both integrated onto our Raspberry Pi board. The first script is the pip detection script. It uses computer vision to detect blobs and then filters out the numbers that are too large. For the purpose of this demo, we also drew contours and then printed it on the left side so you can see the accuracy. Our second and more generalized script is the actual digit number detector. This is broken up into two phases. The first of which is the actual pre-processing of the images, which then the classifier, the second phase, then predicts which digit it is. We begin by identifying the contours within the image and applying a binary mask to filter out the background. We extract the region of interest and then further extract the digits, which we then calculate the angle of rotation and align to the vertical axis. We classify these numbers, rotate 180 degrees to test whether they've been flipped upside down, and then we proceed to the rest of the classification. Now, this is the machine learning component of the project. For those of you who don't know, what we're implementing is a convolutional neural network, which is basically a computer algorithm which attempts to mimic the human brain's decision making. As illustrated by this image here, it's composed of multiple layers, and in each layer it breaks down certain features which, based on whichever data set it was trained on, can then predict classes. So in this case, the digit 2. This is obviously a pretty broad overview of a relatively complex topic which we can't summarize in 20 seconds. However, our team had experience previously and was able to produce a first demo by the end of the first semester. We're pretty happy with the accuracy. However, as you guys can see, there's definitely room for improvement, especially when we consider we have to implement it onto the Raspberry Pi board where the hardware isn't as great as a PC. There are other remaining technical challenges, the first of which is creating a master script which incorporates both the pip and the number detector. We have to improve the accuracy on this, and then we have to actually integrate it onto future prototypes. Then we have to consider harder cases such as multiple digits when we're rolling 20-sided numerical die. On the hardware, the guys have to put together the second prototype, and then we have to consider alternative roll detection methods such as accelerometers. We also have to include battery operation to make sure that this is portable. Finally, we'd like to thank everyone who's given us support and contribution on this project. Appreciate you for all coming here.